moles at KS5. It's because they never paid attention to the concept of valency, compound formation, and relative molecular mass, because almost every molar calculation is down to your accuracy to be able to calculate the relative molecular mass as quickly and as authentically as possible. So first of all, I'd like to take you through how to mix and match compounds and elements into compounds based on their valency. So if we've got zinc atom and a chlorine atom, it would be zinc chloride because the -1 goes here and the 2 positive comes here. So in chemistry, chemical IUPAC convention, you don't mention the -1 or the +1, so you leave it like that. You leave it as zinc chloride. It is akin to the concept of Cu2O2, where empiricity rules, and you write it as CuO, copper oxide, copper 2 oxide, but you make sure, according to fulfill the IUPAC standards, you mention copper 2 oxide. Now, if it were copper 1 oxide, it'll be Cu2O, but this one's a temporary compound. It gets converted to CuO very quickly, so the plus and the minus don't come down. It's just the magnitude that comes on the opposite. So it's basically a cross multiplication of charges. If we had sodium and sulfate, that would be Na2SO4 because of cross multiplication. And we've got it here. Now if we take aluminium sulfate, slightly more complex, we would get this. If we had aluminium phosphate, both, so as you can see, this one is divalent, trivalent, divalent, monovalent, divalent, monovalent, monovalent, divalent, and then divalent. So in cases where both entities are trivalent or isovalent, i.e. of equal same valency, trivalent, pentavalent, tetravalent, they are harmonized as because the 3 negative and the 3 minus cancels. And even if it doesn't cancel, according to IUPAC convention, Cartesian convention, this 3 would be nullified anyway. Now, having done that, we'll move on to iron sulfate. So how does iron sulfate